Hello, everyone, and welcome. My name is Márton Braun. I'm a developer advocate at JetBrains, working on Kotlin, Kotlin Multiplatform, Compose Multiplatform, and all of these great technologies. And today, I want to talk to you about going multi-platform with your Android app. So taking an existing Android application and then migrating that to KMP to run it on other platforms as well. So let's get started. That is not quite what I'm looking for. We're trying to go for Kotlin Multiplatform. We're going to go back, try again. So before we go Kotlin Multiplatform, we're going to do a bunch of steps to get there. So we'll start with some strategy. I want to talk a bit in general about how you can approach a migration like this. Then we'll talk about modernizing an existing Android app. So not doing anything with multi-platform yet, just bringing your apps up to the latest best practices, which will help you go multi-platform later on. Then we'll do every preparation step we possibly can, still without using multi-platform, but making the app more ready to go there. And then finally, we'll see how we can actually start shipping to KMP. So let's start with some strategy. So the first thing, and probably the main thing I want to get across in this talk, is that you should do a migration like this incrementally. So you should really take your time, make sure that you're not trying to do everything all at once, because we know that you can't stop the universe while you want to move to KMP. You have to keep shipping features. You have to keep maintaining the existing app. So incremental is going to be the name of the game here. Or to put it shortly, don't be the person who opens that PR, right? No one wants to deal with changes like that. So some general advice here at the start. Usually, if you have existing, say, Android and iOS apps, then the approach that most people tend to take, and we've heard that at the booth several times today as well, is a bottom-up migration. So taking something from the data layer, maybe networking, business databases, something like that, taking that from the Android side, making it multi-platform first, migrating to multi-platform things in the Android app, and then sharing it between the iOS and the Android app. And then, of course, you can keep going depending on what your project's needs and preferences are. So if you want to share your business logic, you can do that. If you want to say keep sharing layers as you're going up the stack, you can keep migrating things to multi-platform. And again, if you want, you can end up with a 100% Kotlin multi-platform application, including shared UI as well. Now, zooming into an actual Android project, let's say that you have a project that looks something like this. You have an Android application module at the top, and then you have a bunch of different Android libraries that you have modularized your app into. Now, one thing you can do for a very quick start with KMP is you can start with a brand new module. You can create an empty module, which is configured from scratch with all the latest best practices for KMP, and you can start putting code in there. And you can actually start depending on that with your iOS app right away so that you immediately start shipping shared code. So that can be like one function at the start or one class, one little utility, and then you can add more and more features over time if you want to. So over time, you can grow that shared module. And you can also, for example, take some existing functionality from some of your Android modules, move them over into the KMP module, and maybe you get to eliminate some of the existing Android modules and Android libraries that you had there. It's important to mention here that Android libraries can still depend on that KMP code, so dependencies like that are possible. And at least for the Android part of your implementation, you can also have dependencies from the KMP library to existing Android libraries that you have in your project, minding that if you're also shipping that for iOS, then you'll have to implement that part separately for iOS, whatever functionality you pulled in from an existing Android library like that. So you can do all of these things. You can also, as this shared module grows, you can, of course, modularize it, break it up into several libraries, just like you would do with Android modules. So this quick start approach can seem very attractive. It gets you shipping code right away. But there are a couple of problems that you might also run into. For example, when I say you can just move things from the Android libraries into the KMP libraries, some of those moves for some classes, some files might be non-trivial. There might be things that don't move so easily because they actually depend on Android or JVM-specific stuff that will not work with multi-platform. You might also introduce fragmentation, because as you're moving files over, maybe you'll find yourself migrating usages of Android libraries. For example, if you're using Dagger or Glide or something like that in your Android code, as you start moving bits of your code to multi-platform, you'll have to replace those with multi-platform solutions. So you might end up in this universe where you have a bunch of Android libraries and you have a bunch of Kotlin multi-platform libraries, and they're on a different stack. And that kind of fragmentation, especially if it's across a lot of different dimensions, like in this illustration here, can make it pretty annoying to work in a project, because different parts of the project use different libraries for the same kinds of problems, and you have to do interop constantly across many dimensions. So that's something that you might also not be too happy about in your project. And finally, if you just start with a brand new KMP module and you start shoveling things over there, then you can also introduce structural changes that might be unexpected. So again, if you have other teams working on features and things like that, then if you suddenly pull a module entirely because that functionality now lives in another module, that can cause some problems and some annoyances, constantly having to rebase on each other's changes and things like that. So other than this quick start, what's another approach we could take? Well, we could have a more relaxed, a more in-place migration, which is an option. So let's say that we have, again, this Android app, and we start by scoping out which parts we think we're going to be able to eventually migrate to Kotlin Multiplatform. So let's say that we want to take these 5 modules, and that's our complete scope for the migration. That Android module there, it probably does something very Android-specific, maybe contains widgets or something like that, that we know is never going to make it to KMP anyway. Now, we don't want to have to wait for the entire scope to be migrated to KMP, of course, to start shipping something for other platforms and getting value out of this whole thing. So it's probably also worth marking a smaller scope, which is kind of the initial scope, the minimum viable thing that we want to see converted to multi-platform. And that's what we would initially start shipping once those couple modules are ready to ship. We can also put this on a visualization like this, because as you're going from 0% KMP to 100% KMP, you can actually do that work and keep raising the KMP readiness of these modules over time. So you can perform different migration steps, and eventually you'll hit the place where your initial scope is ready and it can start shipping. And then, of course, you can catch up, keep migrating the other modules, and add more and more functionality over time. But I want to emphasize that you don't have to do this strictly module by module. You can kind of do this in parallel, step by step, across your different pieces of code. What I also like to do is visualize this as the units of work that you need to do during a migration. So on the vertical axis here, we have all of our modules. And then on the horizontal axis, we have all the different migration steps that we need to do. So all of these little boxes here are individual units of work that you could, in theory, perform one by one to get things to KMP. So once you visualize this and you have some idea of what it's going to take to go to KMP, you have to think about what order you want to do these things in. So one thing you could do is you could perform all the steps in your first module. You could perform all the steps in your second module. And then you're in this happy, ideal scenario. These are ready to ship. You can start using them on Android and iOS at the same time, for example. But this, again, has some problems. For example, the fragmentation I mentioned earlier. This might very well introduce a bunch of fragmentation to the tools that you use. And there are also problems around changes that you can't really make per module in your project. So for example, if you need to update a dependency version, those kinds of settings are usually global. So it's very hard to update a dependency and make the matching changes in your sources only in 2 modules within your project. You usually have to do that across the entire project at a time. So another approach that you could take in terms of ordering your work is you could start with all of those things that you cannot do separately. So for example, if there's a version bump that needs to happen for KMP migrations, maybe you do that across your entire project, because that's how versioning generally works. Or if there's a library migration and you don't want to leave your project in a fragmented state where you're using both the old and the new library at the same time, then maybe you could prioritize going through that migration in all of your modules. And once that's done, then you move on to the other migration steps. And once you have these tasks that are really global concerns and that you want to do first, then you can, of course, double down on that initial scope to make sure that you make those modules multi-platform and actually start shipping them. So really, the migration is a balancing act across these two axes of how much you want to focus on single modules and how consistent you want to keep your project at the same time. Obviously, if you want to ship quick, you want to do single modules as much as possible. And if you have all the time in the world and the luxury of that, then the easiest and most convenient thing to do is to go step by step across all of the modules at the same time, keeping everything perfectly nice and consistent along the way. There was also a fantastic talk about migrations to Compose from Christina Lee a couple years ago at Kotlin Conf, where she talked about how Pinterest migrated to Compose. And some way in, they realized that they weren't just migrating to Compose, they were also migrating to coroutines and unidirectional data flows and maybe even more things at the same time. So this, again, is a lesson in pacing yourself, because it's very hard both on your code base and on your team if you're trying to do multiple different migrations combined. That can be very hard to manage. Finally, for the intro here with the strategy section, I'm going to be breaking down all of the migration steps that we're about to look through in the remainder of the talk into the smallest possible steps that are viable on their own, just in case you want to break that down like that as you're going through the work. But of course, if those steps end up being very small, or you can, in practice, combine a bunch of those steps together and put them on the same PR, for example, you can always feel free to do that. But it's good to know which steps are possible and which steps are not possible to take on their own. Right. So we're going to start by modernizing our Android app. And I mean, if you're lucky, all of this section can be ignored for your app, because you have a beautiful, perfect Android app which uses all of the latest conventions, all of the latest libraries, and has no legacy in it. But maybe that's not what you have. So maybe you'll need to start by modernizing first to get ready for KMP. First things first, if you have Java code and you want that code to run on multi-platform, the first step is going to be the Kotlin migration, right? It's Kotlin Multiplatform, after all. So we have documentation for this. We have the converter in IntelliJ IDEA. We have this covered in the AI skills that are published for Kotlin. And of course, you can also use whatever agentic solutions and AI tools you want to use for migrations. I'm going to show a lot of links during this talk. You'll have a QR code that collects all of them at the end so that you don't have to catch each of them individually. Once you're done with that, another similar migration is going to the Kotlin DSL for your build scripts. If you look at multi-platform materials or samples, you will have a very hard time finding anything that deals with Groovy still. So it's a good idea to go through the migrations that are required to run your build scripts on Kotlin, because you're going to have a much better time with that once you are on KMP. Next, another tooling migration is going from kept to KSP. So kept is a legacy tool to support running Java-based annotation processors still with Kotlin code by generating Java stubs and things like that. And that's also a Java-only solution. So if you want to use your annotation processors with multi-platform, you'll want to move to KSP, which is faster, Kotlin first, and most importantly, ready for multi-platform. The good news is about this is that most libraries have been ready for KSP for years. So here are some popular examples that all already support KSP. And a lot of the time, upgrading is just a matter of bumping a version and then replacing kept with KSP in your build scripts. Something to note is that once you eventually get to Kotlin Multiplatform, you will require just a small bit of extra configuration where you'll have to individually enable KSP for all of your platforms versus just the single dependency that you had on Android. But you can do that once you start configuring KMP. Next, as a preparation step still and modernizing, it's a great idea to update all of your dependencies to latest. Things like the Gradle version of your project, the Kotlin version, the Jetpack Compose version, the AGP version. If you're on the latest versions of all of these, first of all, you get a lot of bug fixes and performance improvements for free. And it will also be easier to move to multi-platform because, once again, compatibility bugs and things like that are much less likely to occur if you're on the latest versions. Of course, these tools love depending on each other, with AGP requiring a Gradle version and so on and so on. So I also collected a bunch of links for you here that let you navigate which version is compatible with which other version. Then we have a fun migration, still while modernizing, which is adopting coroutines. Multiplatform, you'll find, is very coroutines first. Of course, the things like the Java threading APIs or RxJava are not available for multi-platform because these use threads, among other things, which we even have platforms that don't have threads at all, that are single-threaded, like our web platforms. So coroutines are a great replacement of that, and they are a pure Kotlin-first async solution. Also, if you're going to be sharing UI and you're using Compose for that, Compose is also very heavily tied to coroutines, both in the implementation and APIs. So having the rest of your code base use coroutines for its asynchronous work is a great idea because it will integrate nicely with Compose. Of course, this is a migration that you can do incrementally. So if you're coming from something like RxJava, we have great interop libraries that let you perform this module by module, even incrementally within a single module. And you can convert Rx types to coroutine types back and forth as you do the migration. Speaking of UI sharing, which I've already mentioned here in the previous slides, if you want to share your UI on multi-platform, XML views from Android are unfortunately not going to make it. You can't run those on other platforms, but you can run Compose code on other platforms. So if you have pieces of your UI that you want to share, you will have to make sure that that's written in Jetpack Compose. Once again, the Android developer docs have very extensive documentation on how you can move from views to Jetpack Compose. And I'll keep saying this during the talk, this is also something you can do incrementally. So even within a single screen, there are, of course, interop APIs between the two UI systems. So you can move node by node, view by view, if you want to. With that, we have a beautiful Android app, which uses all of the latest standards. And we are ready to start making steps towards multi-platform. In this next section, we're going to go through some steps that you can do before actually starting to use multi-platform that you would have to do once you go to multi-platform. But if you do it in smaller, separate steps as preparation, then you can keep your changes smaller, easier to review, easier to manage, and you don't have to make, again, like huge changes of like going multi-platform and implementing 20 steps at the same time across a bunch of different modules. So we just talked about Compose and migrating to Compose. And that migration is actually an example of a broader migration, which is just moving to multi-platform APIs in general. Because once you work with Kotlin Multiplatform, you'll have a bunch of different source sets in your projects, where you'll have a common main source set, where you can put platform-independent code. So that's the code that's shared between all of the platforms. And then you can have source sets that are auxiliary source sets, which can have platform-specific API calls and dependencies. But of course, you'll want most of your code to be shared between platforms. That's the point of multi-platform, after all. So you'll want most of your code to be shared and land in the common main source set. For this to work, you might have to replace a bunch of libraries that you're using that are tied to the JVM or to Android with alternatives that are ready for multi-platform. I'm not going to do an exhaustive list here. Here are just some examples of JVM and Android libraries that you might replace with KMP libraries instead. You can look at things like OKHTTP and Retrofit, for example, which are JVM libraries. And there are alternatives here like Ktor and KTorFit for Kotlin Multiplatform. Or it's worth mentioning the Kotlin standard library, actually, that's here at the top, which, of course, is a multi-platform library. And it contains a lot of functionality that you might use from the JDK, from Android utilities, from other utility libraries. So it has things for working with collections, regular expressions, UUIDs, stable since yesterday, and a bunch of other features. And of course, the happiest path that you can be on coming from Android is if you already happen to use Android libraries that are also just multi-platform. So if you already used Coil for image loading, for example, then you'll have very minimal migration work to do. You can keep using the same APIs, the same library. Maybe you just have to bump its version so that you're on a multi-platform release. And then there are other libraries that are also similarly like already good to go if you're on those. For example, if you're using Coin for dependency injection, that's a multi-platform library. If you're using Android X libraries like Room or Data Store, those are also available for multi-platform for Android, iOS, desktop, and even for web as of a couple months ago. So these libraries and these APIs, you can just take from Android. You can keep using your same skills there and use them as is for multi-platform. If you still need to find multi-platform libraries after that, if there's something that hasn't been covered, you can always go to klibs.io, which is our catalog for Kotlin multi-platform libraries. It has more than 3,600 KMP libraries listed now, so you'll probably find a solution for just about any kind of task, and it should work on the platforms that you need it for. If you're not quite thinking of KMP migrations just yet, or you're not sure when your Android app might make it to multi-platform, I would already advise you to err on the side of multi-platform. By that, I mean that if you're making new technology choices, you're picking up new libraries for your Android app, you might as well pick libraries that are multi-platform so that if your code ever needs to make it to other platforms, it will be more ready for that, instead of locking yourself into another JVM library that you add to your project, just in case that you'll get to run your code on KMP someday. So for example, if you're migrating away from JSON finally, then I wouldn't go to Moshi anymore, which is a JVM-only library, but I would go to Kotlin X serialization instead, just in case it will be used on other platforms later on. Now, if you cannot find a library solution out of all those thousands of libraries somehow, you need something super specific, you can, of course, always reach into platform-specific APIs from Kotlin Multiplatform. That's one of its superpowers. If you need to reach into UIKit or AV audio player things on iOS or anything like that, you can just directly reach into those APIs. And we have documentation and videos about this that you can check out after this talk. And if you want to implement something like this yourself, then what you can use, for example, is the expect actual mechanism here. So with the expect keyword, you can declare a function in your common code which doesn't actually have a body, doesn't have an implementation. And then you get to implement that function using the platform APIs of each platform with actual keywords. And while this serves you well in simple cases, there's also another pattern that I want to highlight, which might be useful to adopt even while you're preparing for KMP. You can shape your APIs in a way where you adopt them into this structure, which is this kind of setup. So here we have a common interface, which declares some functionality. We can imagine that it has properties and methods that do something. And then in our common code, we can have a initializer function, which we expect the apps to call whenever they get started. And that can take the interface implementation as an incoming parameter. The beauty of this is that each of the platforms can then have their own implementations of this interface. And those implementations can look very different from each other, potentially. Once again, they can use the platform APIs for Android and iOS. They can just interop with those APIs. And they can also have different parameters, for example. So if you have something that requires access to a context on Android, you can just take a context as a parameter only for that implementation, while the iOS class could have completely different dependencies and completely different structure and implementation. As probably the final step here in the preparation phase, I want to talk a bit about AGP 9, which brought some exciting changes for Kotlin Multiplatform. Which you also will have to comply with once you move to KMP. So it's better to be prepared for them and not have to do them in the same migration step. So one of these things is that if you have library modules that work either with variants or native builds, these things are unfortunately not supported in Kotlin Multiplatform libraries anymore. So for the purposes of the Android Gradle plugin, Kotlin Multiplatform libraries are single variant, so you can't have different flavors. You can't have different things for debug and release builds. So you'll have to move any code that deals with variants or native builds into different modules. One way that you can do this is you can move this code up into your application module or to like higher up existing library modules that are going to remain Android modules, because those, of course, still support these features. Or another way you can go is you can extract this kind of functionality into a separate Android library. So you can pull this out into a new module. You can keep that as a native Android-only library. And then the KMP library can depend on that for part of its Android implementation. So that way you still get to use these things, and you'll be able to access them from the KMP side as well. Right. Another thing that you often combine with variants is using build config values. This again, because we don't have variants, this is also unsupported in KMP libraries. So if you need to work with build config values on multi-platform, then you can migrate to community libraries that can serve that same purpose. So there are libraries like build config or Gradle build config plugin, which provide very, very similar APIs to what the Android Gradle plugin gives you. And you can have custom fields that you populate from Gradle and then access at runtime from your source code. Right. With that, we have done everything we can before we actually flip the switch and go to Kotlin Multiplatform. So let's see what this actually takes. We could theoretically start going Kotlin Multiplatform with any of our library modules that we have in our imaginary application here. If we wanted to, we could do it with like some module there in the middle, although usually, again, a bottom-up approach and starting with the leaf nodes is recommended. But the reason why we could do that is because the way we're going to approach this, again, step by step, as small steps as possible, is we're going to first set up the KMP plugin for just Android. So we're going to create a multi-platform library instead of the Android library. But for a start, we're only going to target Android with the multi-platform library. So we're going to do single platform, multi-platform, and then we'll do the rest of it. So what does that take? For Kotlin Multiplatform on its own, so the business logic side, we'll need to swap the plugins, start using the KMP plugin. We'll need to move our dependencies and our sources around a bit. And finally, we'll have to opt in some things that are required by AGP 9. And then if you also want to do UI sharing, you'll, of course, have to enable Compose Multiplatform. You'll have to make sure that your previews continue working by updating some of the config. And finally, we'll use multi-platform resources. So let's do that step by step. So first, instead of having an Android library, we're going to use the KMP plugin, and we'll pull in the Android Multiplatform library plugin to go alongside it for Android support. Then we're going to take our existing configuration. Let's say we had like a top-level Android block like this in our build configuration. We're going to move that under the Kotlin block, because this now becomes the configuration for the Android platform within a multi-platform library. And this briefly used to be called Android library, which you might have seen in some materials. It's, again, just called Android. You don't have to worry about Android library anymore. You can just keep calling this block Android. Now, once you move this under the Kotlin block, you'll see something like this in your IDE. So most of these things will become unresolved. So we'll need to do some fixing to continue the build working. Continue to have a working build. So the first thing here is setting the SDK version under default config. I already said that we don't have variants anymore. So, of course, it doesn't make sense to set something in the default config, but it does make sense to set a minimum SDK version. So that just becomes a top-level property. You can just move that outside. Then we have compile options here, which have to do with Java compilation targets. With KMP, we're probably not compiling Java anymore. So you can either just get rid of that configuration, or if you want to set what the Kotlin compiler should target, you can use compiler options and then JVM target, and you get a nice typed API where you can set the bytecode version. And then there are build features that you might have enabled in your Android block, like compose or build configs or things like that. These are either on by default or unsupported in KMP libraries. So usually, you can just get rid of that block as well. Right. Up next, I said that we need to move our dependencies around. So let's see how we can do that. So with Android, you have a top-level dependencies block. You have all of your dependencies listed in there. With Kotlin Multiplatform, we'll get a dependencies block for each source set. So we can have dependencies that are applied to the common part of our code, and we can have separate dependencies for Android, iOS, web, desktop that we can add separately. Now, ideally, most of your dependencies just move into common main dependencies because they work across all of the platforms. But if you need some dependencies, for example, only for Android, like the Android X preference library or something like that, then you can move that under Android main dependencies. Next, we're going to move our sources around, which is going to do something very similar. Instead of having a single source folder, which is like src main Kotlin or something like that, instead of that, we're going to have src common main Kotlin, where our shared code can live, which will compile to all platforms. So we can take all of our sources, move them to a new location in the project. Then we get to AGP 9 opt-ins. So there are some things that are enabled by default in Android libraries, but are not enabled by default for Android multi-platform libraries. For example, Android resource processing is disabled by default to save performance, but if you need to use resources, you'll want to re-enable that. Similarly, test features are disabled by default on Kotlin Multiplatform libraries. So if you want unit or instrumented tests or host and device tests, as they now call them, you have to use those respective blocks to re-enable them and start using those features. As a fun fact, you can also still compile Java code only for your Android implementation if you really have to for some reason. So you also have to opt back into that, although hopefully you don't have any Java code left at that point. Right. So that's the KMP part of the setup, bringing us to Kotlin Multiplatform library that targets Android. And now we go to the UI sharing part on top of that. So what this requires is adding the extra plugin, so making sure that Compose Multiplatform is also enabled as the first step. Then you can swap out all of your dependencies that were Jetpack Compose dependencies, so they came from the Android X Compose namespace, to multi-platform dependencies that give you the same APIs. So you can use org JetBrains Compose dependencies instead for things like the Compose runtime, UI package, foundation, material, theming, all of these things. We just have a multi-platform equivalent for them, and you can use those across all platforms with the same APIs that you know on Android with Jetpack Compose. For this, you might have to look up the versions of all of these dependencies. The best way to find these is on the GitHub releases for Compose Multiplatform. So there we list all of the versions that go together and are compatible. So if you want to pull in material and lifecycle and navigation and things like that, you can find all of the correct versions for a given CMP version on the GitHub release pages. Then you'll want to make sure that you have previews working. So the preview tooling that you have on Android with Compose, with the @preview annotation and all of the infrastructure that's built up around it, with multi-previews and preview parameters and all of these great things. This also works with multi-platform. So if you create Compose code in common sources, you can preview it the exact same way with the exact same tooling. All you need to make sure is that you have the right dependencies, which look something like this for multi-platform. And then, again, you can use the exact same kind of previews. You can annotate composable functions, and you'll see those in the IDE. For this as well, we have a great documentation page that's going to be in the links at the end that you can use to make sure that you have the correct multi-platform versions of dependencies. Finally, with enabling Compose Multiplatform, you'll want to migrate to Compose Multiplatform resources. So if you used the Android resource system before, for things like strings, drawables, fonts, or maybe just like files that you packaged with your application, you can move to using the CMP resource system instead, which can support essentially the same types of resources and then load them with very similar APIs at runtime. Again, details of how you do this in Gradle config and so on is going to be in the docs, but it's a very similar experience to what you see with the resources on Android. It has support for qualifiers, for going to alternative resources per language, per dark mode switch, and things like that. Right. So with that, we have this state of our application, finally, where all of the modules that we wanted to migrate are now Kotlin Multiplatform libraries. Everything still compiles, but everything still only targets Android, right? We have just a single platform in each of our modules. So it's time to start adding more platforms within that Kotlin block. We have Android so far. We can add more things besides that. Usually, on the mobile use case, you probably want to add iOS next. And that's actually a great platform to add, because this is the point when you start adding iOS to your different modules, when you would see anything that's in common main but isn't actually compatible with all of your platforms start to break. So if you use some JDK or Android-dependent API in your common main sources, this is when your project's builds would start failing, because now the same thing actually has to compile to native code that will run on iOS as well. In theory, if you followed all the steps, then this doesn't happen here. But of course, there might always be surprises about this. So this is a good time to backtrack and figure out what exactly you missed and fix up and make sure that everything that you use in your APIs is ready for multi-platform. Here, you can go module by module. Each of the modules will only be able to run iOS if all of its dependencies also support iOS already. So in this case, you will be forced to start with the leaf nodes and then build up from there. Then you can, of course, add other platforms as well. And even if you're very focused on mobile, I don't want you to discard any of these platforms because they can be really useful. So for example, there is JVM. So you can run your Kotlin Multiplatform apps, including with Compose UI, on the desktop, which gives you, for example, a very fast development loop because running things on the desktop compiles and runs very quickly. It only requires a JDK node, simulators, emulators, anything that you would need to have set up on your machine. And if you work with Compose code, then it also gives you Compose hot reload, which is a great feature to iterate on your UI quickly. And then there's also the web target, which is primarily based on WASM, especially if you're using Compose there as well. And the web can be a great platform to easily host your apps and test things. For example, you can have your CI pipeline build all of your changes for the web. You can have those deployed as separate web pages. So you can very quickly test changes on your UI or in your business logic by just launching a web page that your CI hosted for you without having to download an APK, install it, replace an existing APK on your device, and things like that. So that's also full of possibilities. Right. Wrapping up here, I want to talk about one last topic, which has to do with integrating all of these beautiful KMP libraries that you build in your application with iOS. So let's say that we have all of these KMP libraries. We've had the Android app that depends on some of these library modules, maybe like this. And then the iOS app comes into the picture. And it might make sense to you to try to depend on the same modules, like whatever's at the top, just like what the Android app uses, from your iOS apps. But this is actually something that you want to avoid when it comes to KMP because of how the compilation works behind the scenes. So if you depend on two libraries like that, those will actually produce two different iOS frameworks, two different native binaries that are independent of each other, which all encompass the left and the right subtrees here that are under those two modules. This has certain problems because you're probably duplicating a lot of the code between these two binaries. For example, the Kotlin standard library would end up in both of them, and so on. And if they have common dependencies, then the types that they have, these duplicated types, are also going to be incompatible with each other. So you don't want to end up with multiple frameworks like this integrated into the same app. So what can you do instead? You can introduce something that we call an umbrella module. So you can have a module that collects all of your tree, all of your dependencies that you have, consumes them in a single module, and then you depend on that with your iOS application. So this way, everything that you have in the KMP world gets combined into a single framework, a single binary, which is a lot more optimal and avoids duplicating anything in there. This basically just is a couple lines of difference in the build configuration. So all of the other modules just declare the iOS target that they can build for it. And in this one module, you would configure that this one can actually be built into a framework with a couple lines of code like this. Now, something interesting here is how you're going to organize your code between different repositories and how the publication is going to work, depending on what kind of setup you have. Now, as far as the Android app concerned, it really doesn't matter what it depends on. It can depend on some of the shared libraries on its own. It can depend on the umbrella module. Anything will work on the Android side, even across repositories. What's interesting is the iOS side, because if you're in a monorepo, then your life is super easy. This is basically the ideal scenario. It's the easiest thing you can do. Here, if you make changes to your KMP code, you can put changes that you need to make on the iOS side on the same PR. You can keep these always completely perfectly in sync. So this is a really easy situation to be in. But of course, you might be in other setups as well. Maybe your KMP code originates in your Android repo, and the iOS repo is separate. Or maybe you have 3 repositories because you have a KMP one and then an iOS and an Android one separately. This gets a bit more difficult because if you have multiple teams changing maybe multiple features in the KMP part of your code, then that gets built into a framework at the same time, into a single umbrella module, which then you publish into SPM, something like that. You pull it in to your iOS app, And whenever you bump to a new version of this framework, you'll get all of the changes from all of the KMP parts of the project, right? So if you're trying to just update your feature, you might see API changes from other teams on other features at the same time. So this makes integration slightly annoying, potentially. What you can do to circumvent problems like this, and this is something that we've been looking at and recommending more and more lately, is that you can actually move that umbrella module to the iOS side. So instead of publishing a binary from your Kotlin Multiplatform libraries and your features, you can publish those as just Kotlin Multiplatform libraries to like an internal Maven repo or whatever you have. And then you can have a single KMP module with no actual code inside it live in the iOS repo. It can pull in those KMP libraries, and it can be responsible for which versions of each features it pulls in and for assembling them into a final binary, which, again, lets you control when changes from the KMP repo will land in the iOS app, and you can make sure that you're synchronized on those changes and things required in the Swift side of your code. Right. With that, I want to point you to some other interesting things that you might want to look at if you're thinking about using KMP. For example, umbrella modules, project configurations like this. We have that first documentation page on that topic. I didn't really talk about how you can organize all of this within your team that much. So you can find info about that, again, in our docs. We have some great documentation for that. If you're going to work with iOS, you really should try Swift export, which is now in alpha and makes it much, much nicer to call from your Swift code into your KMP libraries. And then, of course, I already mentioned Compose hot reload, which is a fantastic time for iterating on UI code on the desktop target. And finally, we also have a nice migration example of an existing Android app already, which is this Jetcaster sample, which is one of Google's Jetpack Compose samples. We have a full documentation page where we go through how that can be made multi-platform with commits and explanations for the entire journey along the way. So you can check that out as well. With that, I would like to thank you all for attending this talk. Here's the magic QR code that has all of the resources for the talk in a single place. And yeah, you'll find me here after the talk. And we also have a booth outside, so I'll be there for the remainder of the day. So you can ask us all of your questions in detail about Kotlin Multiplatform, anything other Kotlin or JetBrains related. We're going to be right there. So thank you.
It won't be that easy for you to leave this stage.
Oh, we already have questions.
Yeah, we still have 2 questions for you. So, is there a possibility risk that Apple will intentionally screw up iOS support in some way?
We don't see any such risk so far. There are very, very large applications with hundreds of millions of users running on Kotlin Multiplatform. We really didn't have any trouble with Apple or the App Store so far.
Right.
They are just native applications. Like by the time it's compiled, it gets pretty hard to tell that it's even a KMP application.
Right. And for me as an outsider, you know, like if I should now pick a framework for my application, is KMP stable enough, production ready at this moment?
It's stable, it's production ready. The only thing that's still in beta is web support for Compose. But everything else, for example, iOS and Compose Multiplatform on iOS has been stable for quite some time now. Okay. Again, we have a lot of apps already using these. I'm happy to talk about them at the booth.
Okay, perfect. And the last question is, what's the progress of Compose MP, which we mentioned, a resources preview in Android Studio?
If you update to Quail, which came out 2 days ago, it already works. I can also show that to you on my machine if whoever is asking the question can find me afterwards.